Hello students, I myself Professor M. N. Jadhav from KKW Polytechnic Nasik, a faculty in Electronics and Telecommunication departments. Today we are going to learn the different commutation methods related to thyristor devices. So first we'll learn what is commutations. Commutation is nothing but the process to turn off the SCR is called as a commutations. The term commutation means the transfer of current from one path to another. There are basically two essential conditions to make the device turned off. Number one, the anode or the forward current of the SCR must be reduced to zero or it should be below the level of holding current. And second conditions, a sufficient reverse voltage must be applied across the SCR to regain its forward blocking states. When the SCR is turned off, by reducing the forward current to zero, there exist the excess charge carriers in different layers. To regain the forward blocking state of an SCR, these excess carriers must be recombined, and therefore this combination of excess carriers causes the process of reverse voltage across the SCR to make the device off. Basically, SCR, there are two methods of classifications for commutations. Number one is natural commutations, and second, it's called the forced commutations. In natural commutations, we have to use the AC supply, and in natural commutations, the source of commutation voltage is the supply source itself. If the SCR is connected to an AC supply, at every end of the positive up cycle, the anode current goes through the natural zero, and ultimately it applies the reverse voltage to the SCRs to make the device off. This method of commutations is also called sometimes as the source commutations or line commutations or class F commutation method. Second method of force commutations, that is, in this we are going to use the DC circuits of the DC supply. It is different from the natural commutation methods. This commutation circuit consists of the components like inductors, capacitors, which are also called the commutating components. Depending on the connections of these commutating components, they are categorized as Class A, Class B, Class C, Class D, and Class E method. Now, here we'll go the different force commutation methods one by one. This is Class A commutation method. The another name given for this one is also called the self commutation method or resonant commutations or load commutation methods. In this, the commutating components are connected in series with the load, or the commutating components L and C are connected parallel with the load resistance. Here, the figure shows the waveforms for Class A commutation methods. Second method will go for Class B commutation method, in which the other name for this is also called as self-commutations, in which the commutation of the SCR is achieved automatically by inductor and the capacitors. Once the SCR is turned on, in this the LC circuit is connected across the SCR, and hence this commutating component do not carry the load current. Ultimately, the SCR goes in off state. The next method is called as Class C commutations, or it is also called as the complementary commutation methods. In this commutation method, the main SCR is to be commutated with the help of another SCR. In this, the SCR turns off with the reverse voltage of charged capacitor. The figure shows the waveform related to Class C commutation methods. The next commutation method is called as Class D commutations. It is also referred as auxiliary commutations because in this method, the main SCR is turned off with the help of auxiliary SCR with the help of the capacitors. The main SCR with the load resistance forms the power circuits, and the diode, inductor, and SCR2, they are going to form the commutation circuits. The waveform for these circuits are shown in the figure. The next commutation method is called as Class E commutation method. This is also known as the external pulse commutations. In this, an external source is used to produce the reverse voltage across the SCR. For this, a pulse transformer is used to generate the commutating pulse. When the SCR is triggered, the load current flows through the pulse transformer, and if this pulse is applied to the primary of the pulse transformer, automatically an EMF or the voltage is induced in the secondary of the pulse transformer. This induced voltage is further applied across the SCR, which makes the reverse polarity, and the device is going to be in off state. So this is a short introductions regarding to different commutation methods of SCR. Thank you.